Alright guys, so this video is going to be all about deciding whether an equation is linear or not. You're given 8 different equations right here, and you have to try to imagine what they would look like on a graph. In order to figure out what linear is, linear just means when it's graphed, it's going to be a perfectly straight line. So we had a lesson on straight lines or linear equations already earlier in the year where we figured out that you can write a linear equation in slope-intercept form, y equals mx plus b. So our job here basically is just to figure out which ones of these equations can be written in slope-intercept form. If it can be written in slope-intercept form, that means we have a straight line, a linear equation. So we'll start out with a couple obvious ones. Something like letter B right here, y equals 7x plus 1. That is exactly slope-intercept form already. The slope is 7, the y-intercept is 1. That would be a straight line. So yes. Over here, letter D on the right side, y equals 3x minus 6. That is slope-intercept form. A slope of 3, a y-intercept of negative 6. If you want to make this plus negative 6, so that way it looks more like plus b, that's fine. But this is a linear equation. Now, there's some that aren't so obvious, but are actually still linear equations. Something like letter C over here. Y equals negative x, you might say that's not y equals mx plus b format, but it is actually. All that it means, there's no plus b because the y-intercept is 0. I can rewrite this equation and say y equals negative x plus 0, and that's the same equation. Negative x and negative x plus 0, it doesn't change the equation. But now I know my slope is negative 1, and I know my y-intercept is 0, that is slope-intercept form. And since it can be written in slope-intercept form, I'm going to call it a linear equation. If I were to go ahead and graph that, I have Desmos open here, y equals negative x. Yeah, it's a straight line. It just goes through the origin. This one down here, letter D on the left side, y equals 4. That is also slope-intercept. But similar to the last problem, we're kind of missing a portion of it. In the last one, we were missing the b. In this problem, we're missing the mx. Well, that must mean the slope was 0. These two equations are the same thing, y equals 4 and y equals 0x plus 4, because 0 times anything would just make this part go away. But when I write it like this in red, I see that my slope is 0, my y-intercept is 4. That's slope-intercept form. Y equals 4. It's going to be a horizontal line, straight line, linear like this. Now, these other ones here are kind of complex, and you guys don't know how to graph these yet. What we have here are equations with exponents in them. This equation has an exponent of a 2, another exponent of a 2, this one has an exponent of x, and this one has an exponent of 3. Anytime your equation has an exponent that's other than 1, it's automatically going to be not linear. Now this equation right here, y equals 7x plus 1, you don't see it. There's actually an exponent of a 1 right there. That's fine. I'm saying any equation that has an exponent other than 1 will be nonlinear. So x squared, x to the second, 2 to the x, that's not 1, and x to the third, those are not going to be linear. And just to show you what a couple of these would look like, let's see, y equals 4x to the third. Y equals 4x to the third. This is a curvy line right here. That is not straight. That is not linear. The other one was y equals 2 to the power of x. That's also a curved line. So basically, you just have to look at these equations, decide, can you write them in slope-intercept form? Equations like this with exponents other than 1, I cannot write in slope-intercept form, so those are going to be nonlinear relationships.